Hello everyone, welcome to Unacademy, and guys, this is our 11th reaction in the series of name reactions, and today we are going to talk about the Demjanov rearrangement, right? It's a very important reaction, and also as you can see the name says it is a rearrangement reaction. So what is the rearrangement involving? It is a carbocation rearrangement of primary amines via diazotization to give alcohol through carbon-carbon bond migration. So definitely there is going to be a carbon-carbon bond migration, but why is the migration happening? Definitely whenever the migration happens, you are going to have a carbocation. Okay, so this is one of the important reactions of the carbocation intermediates also. So you can count it in both ways. Reactive intermediates का reaction है Demjanov rearrangement, or the in the name reaction also, right? It's common. So the carbocation rearrangement. So first of all, we are going to make the carbocation. How are we making the carbocation? Since we are having primary amines, the molecule that we have taken is going to be a primary amine, so that it can be converted into a diazonium compound. Okay, how is that going to happen? Let's see. So over here guys, the first example that we have taken here today is this molecule over here, and you can see that it is a primary amine, and further by providing HNO2 in the form of NaCl and NaNO2 and HCl and so on, right? It's prepared in situ. So when it is provided to primary amine, it is going to first of all form the diazonium compound like this. Okay, and then further this kind of a carbocation is going to be generated, because you know that nitrogen is a very good leaving group. So it is going to leave, and a carbocation on this carbon will be generated. That is going to give you a major and a minor product like this. Okay, right, so we are going to see the mechanism in a while. First of all, we are going to see that how is the diazotization taking place. Now this is a very simple mechanism, but let's discuss this. Sometimes in the standard books, it is directly given that when you are having HNO2, you are going to form the NO positive, right? This is the electrophile which is going to get formed, and this will be attacked by the amine. Okay, so that is also correct if you write it that way. Otherwise, if you want to write the whole mechanism, it is actually taking place like this. You have your nitrous acid like this, HNO2. It is going to be protonated. Alright, so self protonation is going to take place. It's going to take up a proton. Further, it's going to form a hydronium ion. Now you know that the hydronium ion is a good leaving group. So I think this is how it is represented in many books, that nitrosonium ion NO plus is not going to exist in the free form. It is going to exist in this kind of a form, and when the water is about to leave, it will be attacked by another HNO2 molecule, another nitrous acid molecule like this, through the oxygen. Okay, and if that happens, see, this is how the bonds are moving. Okay, this is how you are going to see the bonds are moving. So the oxygen attacks over the nitrogen, water molecule leaves, and finally you are not getting NO plus. You are not getting NO plus directly, but you are getting N2O3 in the medium. So yes, you can also say that N2O3 is the acidic anhydride of HNO2. That's correct. Okay, so if it is forming, it is definitely going to work as the nitrosonium ion only, because a nucleophile, which is our amine, right, an amine nucleophile can attack over nitrogen and oxygen is going to leave. Okay, so this is how the diazotization is going to take place. They could just like this, we had this molecule over here, the amine, the nitrogen of the amine is going to attack over the nitrogen of N2O3, and this is how the bonds are going to move. So this is a standard way of writing the diazotization, or if you directly want to write that NO plus is formed somehow and you are directly making the amine attack over it, that is also correct. Okay, right, so this is how you are going to write this reaction mechanism. So I have already made this removed this extra proton from here, directly written 1NH. Okay, now further you can imagine that how it is going to be converted. Okay, you can just write it like this also, or you can understand that this is the nitroso AC form. Just like that, it's going to be tautomerism, that this hydrogen over here which is present, the hydrogen can be transferred to the oxygen outside, and it is going to be the oxime like linkage. Okay, and further this nitrogen over here is going to make this oxygen or the OH group leave by grabbing a proton. So water molecule is relieved, and finally you get your diazo molecule. So in the competitive exams, such detailing is not asked, because directly you want to get the product. So you know by looking at the reagent that HNO2 with an amine is definitely going to give you diazo molecule. Alright, something like this. So yes, so this is what we have finally, and we are going to remove the nitrogen, because nitrogen is world's best leaving group, I guess, and this is the carbocation that you have. Now from this carbocation, okay, from this carbocation, either the water is going to attack directly on the carbocation, but since this is a 1 degree carbocation, there is a scope of more stability. So either you can write this product directly, but you know that it is going to be a minor product. Why do you know that? Because this has come from the 1 degree carbocation, which is less stable. There is one more reaction which is possible, that is the rearrangement, and that is why we are going to name this reaction as Demjanov rearrangement. Okay, so let's say this carbon is inserted, and over here there is going to be a positive charge, but since the molecule is all symmetrical, you can give a positive charge on any of the carbon, it's going to be correct, right? Okay, so this is the whole process of forming from a primary amine, forming a diazo molecule, and then creating a carbocation, and then rearrangement which is taking place. This is your Demjanov rearrangement, and then finally water attacks over it. You are okay, this is a simple single bond over here, all right. So you are directly going to get a alcohol. So this is pentanol that you get from the butane amine, right? Okay, so we have one more example, one very good example. Example number 1 for this reaction mechanism. Now as always, you can stop the video, do it by yourself, that what do you think is going to be the correct mechanism as well as the correct product of this molecule over here, right? Okay, so let's begin, guys. So first of all, what are you going to target? You are just able to see that yes, you have your okay, writing it like this, there is a hydrogen above the plane and there is a carbon which is below the plane. But first of all, if there is 5 equivalent of NaNO2 and ACOH, any acid it can be, it is directly going to form HNO2 in situ. This is the in situ formation, matlab ki it is not added directly, it is formed within the reaction medium. Okay, right. So directly you can make the diazonium from here, NO2 plus, and you know that it is going to leave. So let's not waste time and make it leave. And yes, this is what you are going to get. A carbocation on the carbon which is below the plane, and there is our hydrogen. So further, now we are going to talk about the rearrangement, that who is going to migrate. Here comes the migrating aptitude. So guys, this carbon over here and this carbon over here, there is competition between these two carbons. So definitely the benzylic carbon is more electron rich, and right over here it is going to migrate. So what are you going to get further? You know that if a 6 membered ring is going to, one of the carbon is going to migrate, there is going to be expansion, right? So this is the ring expansion that is taking place. Okay, so the ring expansion is going to give you something like this. Let's say we are going to get a 7 membered ring. Alright, there it is, the 7 member ring, and this carbon is inserted in between these two bonds. So what I can do is I can write the whole thing over here now. Yes. Okay. And the carbocation is going to be now on the junction carbon. Why is that so? It is on the junction carbon, guys, because already the junction carbon-carbon bond has broken and this carbon has actually migrated over here. So there is a positive charge on the junction carbon, and now you can directly make the water attack over here. But there is one more thing that you have to take care of, that is, even if the water is attacking, it is going to attack from below the plane because there is a hydrogen above. And I hope that you understand this thing. If the hydrogen is above, these two bonds are going to be below the plane, right? Okay, so that is why you are going to make the product something like this. Alright, so here it is. There's a hydrogen and two alkyl groups over here, and further the OH is going to be forming below the plane. So this is your final product. Not writing the whole molecule, that's not necessary. Just have to take care of these two centers, these two junction centers, because these are the junction centers of these two rings. Okay, so yes, this is how your product is going to be. Now further, let's move on to another very important example. This is more important than the previous one. Why? Because there are more than one products which are possible. Let's quickly dive into it and let's see that how is the reaction possible. Okay, so again you have NaNO2 and H2SO4, which means that in situ you are going to generate the HNO2 over here. And finally I'm directly now doing the diazotization because I've already done the mechanism. This is how you're going to make it. And the nitrogen, when it leaves, it is going to make space for a carbocation. Now further, the carbocation has two-way possibility of migration. Either this 3-degree this 3-degree carbon can migrate, and if that happens, the ring is going to expand in this manner. Alright, let me just write it for you once. Okay, here is the oxygen, here is this bond over here, and the ring is going to expand in such a manner that this carbon is now saturated and a positive charge on this one. So I write a positive charge on this carbon over here. So it's going to give you a product. Yes, it's going to give you a product something like this. Here it is, a double bond over here and an OH on this side, and definitely, as you know, the OH is going to be bonded below the plane. Okay, that's going to make it less sterically hindered, right? So yes, this is how it is going to be one of the possible products when the 3-degree carbocation has the 3-degree carbon has migrated towards the carbocation. So this is one of the possible rearrangement. Okay, one of the possible product. Now what is the other product that I'm talking about? The other product is even more interesting because you know that the migratory aptitude of a 3-degree carbon is more than a 2-degree carbon than a primary carbon. But we do have a primary carbon over here as well. This carbon can also migrate. So in the next slide we are going to talk about the second carbon migrating. Let me just write it once. Okay, so this is the carbocation that you had, isn't it? There is a primary carbon and a 3-degree carbon and a 1-degree carbon over here. So if the 1-degree carbon migrates, what is the possibility, or let's say what is the molecule that you are going to get? Let's say again there are going to be 3 carbons on this side, and because the carbon has migrated, the 1-degree carbon has migrated, the positive charge comes on this carbon because this bond has shifted right over here. Okay, very well. So this is a cation that we have formed. Now either the product is going to be directly with this one, either you are directly going to get an OH over here, but that does not happen. This does not happen. Why? Because you have one more migration possible, and that is the migration of the bridging oxygen and carbon bond. Why does that happen, guys? Let me just write the whole structure. Yes, so here is this double bond, here is the bonded oxygen, but now it's not connected to this carbon, it is going to be connected to this carbon. A little bit of a bent line. Yes, Because this is a more stable carbocation, isn't it? More stable carbocation, because now it has become allylic carbocation. Yes. So again, even if the 1 degree carbon migrates, it's not going to stop over there. This is not the product that you are getting. You are going to get a product something like this, that on this side there are going to be 2 bonds like this one, and on this side you are going to get 3 bonds, and this is your product that you are getting, right? This is another product that you are getting. Okay, first of all, 1 degree carbon migration followed by the carbon oxygen bond migration, right? And that leads to a more stable allylic carbocation, and finally this is your product you are getting. That so finally in this molecule, this is a very important molecule, very important. I hope that you will draw and try it by yourself as well. There are more than one product which are possible. This is the major, this is also a very the product is going to be obtained in a nice yield, because the 3 degree carbocation is migrating. The second one also is going to be obtained in a considerable amount, even if the 1 degree carbon is migrating, but yet after one more migration, after one more carbon oxygen shift, we are going to get a stable allylic carbocation. So both of them are going to form in a considerable amount. And this was it, guys. So I hope that you liked the video, and if you did, please give it a thumbs up. Also share it with your friends, guys. This is the most important thing and the best thing that you can do for this channel. And also subscribe to it if you haven't already. And guys, if you are interested in the content, then you can also follow me on Unacademy. I already provide a lot of stuff, lot of free sessions and lot of plus sessions also. So in the plus session, we are more focused on completing the syllabus for CSIR NET, right? So yes, if you like the class, do come up for the next one. Thank you so much. I'll see you in the next video. Till then, bye and keep studying.